Hey gang, I'm MyRadar meteorologist Matt Cappucci. Today we're looking at some of the best and worst weather depictions in Hollywood movies, asking ourselves if they're fact or purely fiction.
Yeah, we got cows. Another cow.
First up, we have Twister, a meteorologist's favorite movie. Everybody loves Twister. Set back in 1969, which is extremely important. We'll talk about that in a second. On TV, you can see the radar there. Most TV stations back then didn't have radar. In fact, the first hook echo tornado signature on TV was found back in 1953, and very rarely did any TV stations, if any had them at that point, have radar. So that's Gary England. He was actually a meteorologist in Oklahoma City for close to 40 years on News 9, CBS affiliate there. Amazing meteorologist, so that part is real. Now, you hear the lightning, you hear the thunder back there, kind of strobe light nonstop. Oftentimes before a tornado, you get crazy lightning rates and an uptick in lightning activity. So that is realistic. Here come the parts that don't exactly add up. We'll see in just a second. Now, the girl wakes up, middle of the night, the mother runs in, says, we gotta go to the storm shelter. But watch what the guy says. Give it just 1 second.
We need to get down to the storm cellar right now. Come on, hey Joe, let's go, let's go.
Come on, sweetie.
Come on, honey,
Don't
hurry.
be scared, Joe. Mama's got you. Mama's got you.
Now, a couple issues here. He says TV says it's big, might be an F5. The Fujita scale to which he's referring doesn't come about until 1971. This is set back in 69, so it hadn't been around yet. Another issue. You can't identify tornado strength in real time, and TV meteorologists never do that. Instead, you have to find the damage after the fact and assign the rating from there. So two big no-nos in this clip.
Bill.
Here's another very popular scene from the movie. You can see multiple water spouts or tornadoes over water right next to each other. The issue here, it's not clear if there are multiple different water spouts or multiple vortices within the same multi-vortex tornado. If we go back just a little bit, you'll actually be able to see these two whirlwinds don't whirl around each other, so it's not one multi-vortex tornado. Oftentimes, a tornado will have smaller funnels within it that rotate about a common center. That's not what this is, and the water spouts are too close to be separate events, so I'm going to kind of deem that bogus right there. Here we go, cows flying across the road. Now, these are very narrow funnels, and actually outside a tornado, outside that area of lifting associated with it, you might actually have some sinking air, so it'd be very unusual for the cow to be floating by without either the vehicle perturbed or the utility poles in the background even shaken at all. So that also bogus. Also, if you're driving in this one little roadway through the middle of a lake, where's the cow even coming from? The cow would have been dropped long ago, unless it's a rare aquatic cow, which I don't think they have. I'm not a farmer, not an expert. Here, this isn't really realistic at all, so we'll rate that one fiction.
I can't feel my legs! I can't feel my legs! Those are my legs.
All right, next up we have a favorite, Frozen. Truth be told, never seen it, so here we go.
Enough, Anna.
No, why? Why do you shut me out? Why do you shut the world out? What are you so afraid of? I said enough!
Okay, now this part right here is somewhat realistic, obviously not that fast, but you can have something form called rime ice. It occurs when you have supercooled water droplets in the atmosphere, basically water that's still water droplets, even at temperatures well below freezing, because it has nothing to freeze upon. Then all of a sudden you get one little ice crystal that forms on something, and then very quickly all that water in the air can form more and more ice. You get these kind of needly structures, and that's sort of what you're seeing right there. Obviously, this is kind of fictional, but you kind of get the idea. You can actually also have something called hoarfrost, which sounds bad, is a real thing. It occurs when you have water vapor in the air that goes directly to ice. It sublimates, and you get this hoarfrost. Of course, with rime ice, you get them usually in smaller crystals, maybe a quarter inch, half an inch across. You don't really get things this big and this pointy. They're not stalactites. Now you see the seasons changing very quickly, summer to winter in just minutes time. Now, obviously, this can't happen as it actually happened in the movie, but on occasion, especially in places like the Black Hills of South Dakota, you can get a stationary front that changes the seasons very quickly. January 20th, for example, 1943, did the temperature fall from 54 to -4 degrees, 58-degree temperature drop in just 27 minutes time as that front came through. In fact, on that particular day, you had people who were driving along and their windshields instantly frosted over when they went from a warm pocket to a cool one, because that's how shallow that cold air mass was. So on rare occasions, you can get temperatures to drop like a rock, just like that. Okay, the snowflakes are falling really slowly or just kind of staying in the air, which, as far as I know, snow falls at about 3 miles per hour. Rain will fall roughly 14, 15 miles per hour, but snow does not really go up. Now, everything here is melting really quickly, and actually you can have that happen, not to this extent, but with something called a Chinook wind. You get winds down the mountain accelerating, and when they go downhill, they start to warm up, dry out. So you can have an air mass completely erode away of any cold lingering in just 20-30 minutes time. Like, for example, that event back in 1943, Chinook winds raised the temperature about 50 degrees in 20-30 minutes time when the warm side of the front came through, as you had those wind change and bring... No, Olaf! Don't go! Oh, good. He's all right. I was getting nervous for a sec. Can reindeer live in warm climates? I don't think they can. So all told, yes, you can have quick temperature swings. Not this quick, but pretty darn quick. So we'll give it mediocre.
Oh, the frogs falling from the sky.
All right, next up we have a scene from Magnolia that features falling frogs. Ouch. Believe it or not, this one is actually possible. In weather, what goes up must come down. So you have to get away to get all those frogs up into the sky, and that would mean a tornado or a waterspout with a very powerful updraft. It sounds apocryphal, but it has happened before. May 15th, for example, back in 1900, a fish fall in Providence, Rhode Island, where people were going around collecting fish, selling them at a local market because a thunderstorm had a waterspout that sucked all the fish into the sky. You got fish 2 to 9 inches long that fell down to the ground. It has happened before. There have actually even been instances with bugs or frogs coated in ice because they go that far up into the cloud where temperatures are well below freezing and come down almost like hail. So this event, a little bit extreme. Not sure exactly how slick the roadways would be with frogs falling, but it can happen and it has happened before. So we'll give this one, maybe, definitely possible.
Thanks to a system of satellites, natural disasters have become a thing of the past. We can control our weather.
Next up, we have Geostorm, which I also have not seen. Right off the bat, we see magma coming out of a roadway, which can technically happen. And this reminds me of an event back in 1943 in Pericutin, Mexico, where actually a farmer found part of his cornfield on fire, found this big fissure opening up, reported hissing noises and this weird smell of rotten eggs. Now it's a 1,400-foot tall volcano, so it can happen. It took about 8-9 years to really become like a cone volcano back in the 1940s and early 50s. Can't happen this extreme, and now I have no idea what the hell's going on. Yeah, this part, definitely not real. I like the guy in the smart car just drove around it. It'd be a good smart car commercial. Now, in the background, you just briefly saw what looked to be a fire tornado of sorts from the magma, from the lava. That can happen when you have that much of a heat source. You get these little whirlwinds to form, so that's something that is real. I'm amazed that these buildings are collapsing and still have power. Kudos to the power company for managing to put indestructible lights inside. Okay, there goes the power. Okay, now we have huge hail... Okay, that killed him. Enormous hailstones coming down. Now, the record biggest hailstone in the United States, 8 inches across, found back in Vivian, South Dakota on July 23rd, 2010. So that's roughly as big as they can possibly get. And for that, you need an updraft for about 140 miles an hour to suspend that stone in the sky. And I highly doubt you could get stones much bigger than that. Yeah, now, and people would not... Okay, you have a minivan-sized chunk of ice. You need like 1,000 mile per hour, 2,000 mile per hour updraft for that. Not going to happen. At this point, these aren't even hailstones. These are what we call mega cryometeors, which are just enormous chunks of intergalactic ice. But what is this? Now, this part, you see a tidal wave rushing towards the coast and freezing. For starters, this would not have caught people off guard. A, because it wouldn't happen, but B, ice expands, so the volume of whatever's in the water would change and push ashore a tidal wave ahead of it, which just hasn't happened here. People are freezing in midair. Cold stunned birds can fall from the air, but you don't have an airplane falling out of the sky because it's cold. Airplanes routinely fly through temperatures down to like minus 80 degrees, so that would never be an issue. Next time you fly, check the temperature. If you get one of those little TV things, check the temperature. I guarantee you it's colder than minus 40 outside. Now you have an insane density of lightning strikes. This also wouldn't happen because one individual lightning strike would balance enough of the electric field nearby that you probably wouldn't need this many others to handle that much charge. So that also would not happen unless you had this crazy, insane field which would neutralize in air. This just... So apparently the plot of this movie surrounds around malfunctioning climate control and satellites, and there has been talk about putting up things in the atmosphere that would decrease how much light and how much energy Earth gets to change the climate, artificially cool it. You would not have effects like this. Like, you could knock Earth out of its homeostasis, its kind of natural state, but this is not going to happen. What is the... Okay, once again, just like in Twister, you're not going to have this many independent vortices around each other that aren't interacting. There's no interaction whatsoever here. This is frustrating. Oh, there's a Burj Khalifa in Dubai. Always want to go there. You know, fun fact, the top gets a sunset 5 minutes later than the bottom because it's so high in the sky. Run. You also would not have a wave this high. Now, the biggest wave I can think of was during an earthquake in Alaska, I think back in like the late 50s, early 60s, that produced a splash 1,719 feet tall that went up a mountain, but you're not going to get a tidal wave this tall. You just can't have that happen. There's not that volume of water. So all told, this... Okay, how is the building leaning that much but not collapsing? All told, this would never in a million years happen, so you can relax. We're going to give this one a 2 thumbs down. But it was entertaining. Next up, we have Ice Age. Oh, this little squirrel guy. So we're seeing what appears to be a big ice breakup that the little squirrel is obviously a little bit stressed about. But this represents the end of the last ice age, a little over 11,000 years ago. And we occasionally do get ice ages. Like, yes, the climate does change, but in the past it was due to something called Milankovitch cycles. Basically, the change in position of Earth in its orbit, whether it be a little bit more like this or like this, so how elliptical the orbit is, the tilt of Earth on its axis, a bunch of different things that every so often you get these alignments that either favor a hothouse Earth or an ice age Earth. So it does happen naturally. And the issue is that the Earth has 3 different stable states. So one is the temperate state that we've been in for a little while. The other is hothouse Earth, which the Earth is warm, tropical, pretty much everywhere. And it's really tough to get out of one of those states because there's no ice to reflect light away. You're warm, so you take in more, you have more water vapor in the atmosphere that absorbs more heat and just kind of positively reinforces. And so as a result, you need a volcano to get out of a hothouse Earth. Snowball Earth, same exact thing. It's really tough to get out of because once your Earth is covered in snow, you reflect light away and you're just kind of in this deep freeze that's really tough to escape. So the concern with climate change just nowadays, we're pushing it much more quickly towards the hothouse Earth scenario than would otherwise happen naturally. Like we're doing this in the order of tens of years rather than thousands of years, which is a big deal. So can an ice age happen again? Definitely. Probably won't for quite some time because we're pushing much more towards hothouse Earth, but down the road, depending on the orbit of Earth, the tilt, all that stuff, yeah, we could have another ice age. Not in our lifetime. So yes, every ice age has an end, and it oftentimes looks like this. Thumbs up. All right, next up we have War of the Worlds, an alien invasion movie. Alright, so obviously it's pretty windy, a storm is brewing, but you have air at the low levels flowing into the storm, so inflow. But at the upper levels, you see the cloud's going to look turbulent, like these little pouches underneath. And this looks like the whale's mouth. In other words, the part of the storm where air is Xing out of the storm, and you have this weird little turbulent eddy mixing stuff going on behind that leading edge of cool air exhaust. And so this should be a region where air is Xing out of the storm, and you don't really have that. Also, why would you have a storm this intense, this warm, during the season where all the leaves are coming down? Like, it looks like fall. Yeah, the little kid is bundled up, but it looks warm outside. Like, now the wind all of a sudden dies down, which also wouldn't happen. It's clear there's rotation above. It doesn't look like that. That looks very laminar, very flat, very nice. You'd have much more rugged cloud material if you were actually talking potential tornado. This looks like an alien invasion. General rule of thumb, if you're outside with your kids and there's lightning coming all over the place, don't be out there with your kids. This does illustrate an important point, though. You can have lightning strike way away from any rainfall. Bolts from the blue are a real thing, so if you can hear thunder, you are close enough to be struck, but...
It's okay. You're fine.
He hid right behind our house.
Yeah, well, it's not gonna hit there again. Okay, because lightning doesn't strike twice in the same place.
That's fake. Lightning does strike twice in the same area. The Empire State Building has been struck 10 times in 15 minutes before, so don't listen to him. Yeah, you can't have lightning without thunder. Lightning heats the air to 55,000 degrees Fahrenheit. Thunder is the shock wave you hear of that air rapidly expanding, and briefly it's supersonic, but you get this kind of ripple wave of sound to go out, and you would absolutely hear thunder. Sometimes, depending on the temperature profile of the atmosphere, you can hear thunder louder if you have an inversion, an increase in temperature with height, that bounces the sound back towards the ground. There are atmospheric profiles that would support the sound going away from the ground, but those profiles wouldn't support a storm, so this is fake. Thumbs down. This is a no.
There's a storm coming. A storm the likes of you have never seen before. They're sharks. They're scary. No one wants to get eaten, but I've been eaten.
Here's a movie that makes every meteorologist cry just a little bit. It is Sharknado 2, because one just wasn't enough. Okay, you can have tornadoes in New York City. It has happened before. Once again, you're not going to have two independent tornadoes that close without some interaction. Any vortices that are close do interact.
You gotta blow those tanks before the storms merge, otherwise it's gonna take out the whole building.
He's right, you can have them merge and combine their vorticity, their spin, to produce a more intense funnel. And oftentimes with tornado families, that happens. Back in 1990, for example, in Heston, Kansas, the old tornado died, was ingested into the new one. Pilgrim, Nebraska, a couple years ago, same thing happened. So we talked about earlier on how you can have water spouts that are enough to carry fish into the sky. You largely wouldn't have, oh, that's nasty. Yeah, you wouldn't have sharks lifted unless you had an extremely powerful updraft, because sharks weigh 600, 700 pounds. To get those in that density up to cloud level would be something. Also notice, it looks like the tornadoes, the Sharknados, are spinning clockwise, and that also wouldn't happen. So overall, I'm going to give this one a no, but it'd be fun if it actually did happen. It'd be kind of fun.
Hello, America. It is my unhappy duty to report to you that the Messiah has failed.
Alrighty, we have Deep Impact, where an asteroid hits the Earth. So firstly, the asteroid would be going so fast, you probably wouldn't even be able to see it if you were this close. I'm going to get the shockwave going out. That would happen. Now, here's something I don't like. You'll notice that around the shockwave, the air goes up, but the clouds go away. That wouldn't happen. If the air goes up, clouds form. Air going down, subsiding, the clouds go away. So this is reverse as to what it should be. You have an immense tidal wave sweeping through, which I would have to imagine would be significantly larger. Now, there is a theory that the asteroid that took out the dinosaurs may also have created something called a hypercane, basically this souped-up hurricane on steroids with winds over 500 miles per hour. Now, we have no record of any actually happening, but computer models say they can if water temperatures get over 122 degrees, which never would in our lifetimes. But it's crazy to think about. Now, that theory says that may have enhanced the death of the dinosaurs, sped it up a little bit. And those storms, because they have such low air pressures, could last for weeks at a time. They'd be very small, only about 60, 70 miles across. But it is something the computer models say is possible and may have occurred the last time an asteroid struck Earth. The other thing too, if an asteroid hit the Earth, you probably wouldn't have a big tidal wave go out, in fact. There would obviously be a very big splash, maybe 10 miles high or higher, but only right near where the asteroid struck. And you would get a wave about a quarter mile high, but it would be a dispersive wave, meaning it would lose its energy as it radiated outwards. The reason tsunamis are bad is because they have a huge length to them where the seafloor moves up and down, and that creates a wave that is more focused in one direction. And the energy isn't really forced upwards until it gets close to the coast. So a completely different set of dynamics for that. So tsunamis, yes, are bad. They don't arrive like a tidal wave. In this case, you A, wouldn't have something like this for an asteroid, and B, it wouldn't arrive as one single wave. So this one, as unfortunate as the scenario would be, would not be a thing. So we're gonna give this one a thumbs down.
It will be so big that even though it's happening here in California, you will feel it on the East Coast.
All right, next up we have an earthquake movie, San Andreas, back in 2015. This one shows the purported big one, which would rock Hollywood, rock much of LA. I want to stop the movie though right here. So you see those lights. Those are likely power flashes from transformers blowing and from arcing electricity, but there have been instances where people actually report blue lights in the sky before and after an earthquake. And there are actually theories that that might be a real thing caused by either proxy bonds in different types of rocks breaking and releasing static energy that discharges, or static building up between different layers rubbing against each other. But it's a real thing. Back during the 2003 Colima earthquake in Mexico, a lot of folks saw blue lights in the sky, and it could be something. Right now, theories are still kind of up in the air as to why that occurs, but earthquake lights are a real thing. Now in this same clip, you see something kind of cool, a surface wave rippling through the ground. There are two different types of surface waves that cause damage during earthquakes. Rayleigh waves make the ground go up and down a little bit, move individual areas like these little circles vertically, and then love waves shake back and forth. So we're seeing the depiction of Rayleigh waves here. So that is true. The issue is that the amplitude, how much it goes up and down, is way over dramatized here, and it's going too slow. They move about 10 times the speed of sound, so roughly a couple miles per second, and you're just seeing it way too slow here. A lot of the buildings in California too are built to sway back and forth to accommodate some of that earthquake shaking, and here everything's collapsing, which I just don't think there's enough seismic energy released that could be realized there to cause this sort of damage. So they get some of the science correct in their depictions, but it's a movie, they over dramatize it. So we'll go meh. They tried.
And remember, my sentimental friend, that a heart is not judged by how much you love, but by how much you are loved by others.
Next up, we have one of my all-time favorite movies, The Wizard of Oz. Every meteorologist loves this. It's pretty much what inspired like half the Mets out there to actually do what they do. So one thing they did that's actually pretty decent, they don't have rain falling at the time of this tornado. It's a classic supercell. There's a rain-free base because remember, the tornado forms in the updraft region, air going up and in. And as a result, you oftentimes don't get rain around it, so you get picturesque views like in this particular instance. But they were good. They didn't have thunder. They didn't have lightning, rain, hail, all that stuff. They just have the tornado there. And you see, obviously, the rain on the right, so northeast of where the tornado is. It's windy outside. They might be in what's called the rear flank downdraft, the cool air wraparound on the south side of the tornado. But look at the debris being lifted up by the tornado. Now, one thing, it keeps moving directions back and forth. Typically, you don't get that much undulation back and forth. So just like we said, they're outside the tornado. The funnel is rather narrow, but they're still getting destructive winds, probably because of that rear flank downdraft, which can happen. This tornado is big and kind of elegant at an angle, and it reminds me a bit of the May 22nd, 1981 tornado near Cordell, Oklahoma. Very rarely do you get ones that are this elongated, nice and structured, but that's what you're seeing right here. And it usually happens when you have an area of cool air kind of upend the tornado and cause that weird shape. Oh, wait a second, the winds are going the wrong direction. Now, I love the scene so much, but there is one flaw. Pay attention to where the tornado is in the background, and the winds are blowing from the right, so likely from the east. You have winds going counterclockwise around the tornado. Here they're going clockwise, so that's a no-no. Now, you can have people actually survive being carried by a tornado. It's happened before, not to this extent. For example, Matt Suter back in Portland, Missouri, in I think 2006 was carried 1,307 feet, so roughly a quarter mile, and survived. So it can happen. You don't want it to happen to you, obviously. Dorothy is an extreme example. Definitely not realistic, but it's cool to think about. The chickens, by the way, would have lost all their feathers, molting both from fear, and the tornado would have plucked them off. You actually can find bald chickens after tornadoes. It's kind of sad. Sometimes they're alive, sometimes they're dead. You probably wouldn't have a grandmother flying around sewing or knitting. Always with the flying cows. Maybe that's where they got it from in Twister. A lot of folks back then did call them cyclones. So obviously none of this would occur, but you can have small outbuildings being picked up and put down by tornadoes, and sometimes a landing can be gentle. Like it does happen once in a blue moon, but it can happen. We'll give them like a C+, B-. I got some of the signs correct, others not so much, but for the time, 1939, they did a darn good job.
I got a jar of dirt, I got a jar of dirt, and guess what's inside it?
So here we're watching Pirates of the Caribbean. One thing that I want to point out, though, in a second, you'll see there looks to be rotation in the sky, and very rarely, other than fair weather waterspouts, you get actual spinning thunderstorms, just because you don't really have spinning parent weather systems that often, other than tropical storms and hurricanes, because there's not much spin down there to work with. The Coriolis effect due to Earth's rotation is weakest near the equator, and so in the tropics, you don't really get that much in the way of spinning weather systems. Now, here we have a whirlpool. You can get whirlpools in the open ocean occasionally, much more likely near the coastline thanks to turbulent currents. Obviously, nothing this big, nothing this deep, but there's one called South-Straumen, for example, near Norway that gets about 30, 40 feet wide. There's one in Canada that has currents about 17 miles per hour, so you can get whirlpools that can be hazardous to mariners, but nothing of this size, scale, depth. So we'll give this one a thumbs down, just downright silly. But it's fun to watch. Next up, we have Mission Impossible, and we're watching a dust storm in Dubai. So now out the window, for the first time, you see this sandstorm getting going. And believe it or not, this part is actually very realistic. Sandstorms can move 40, 50, 60 miles per hour. They're oftentimes propelled by thunderstorm outflow, the leading edge of cool air exhaust ahead of a thunderstorm, so those winds will kick up sand, sometimes a mile or two into the atmosphere. There's actually a very funny technical term for sandstorms. It's called a haboob. Now you hear the car horn. Sandstorms can drop visibility to near zero in seconds, and that's what it actually looks like. The sky's all brown and hazy and kind of tan looking. It's horrible for people's eyes. Asthmatics especially have a tough time with it. It can give you serious lung conditions too. And you get this crazy color to the sky. I've been in sandstorms before and they look exactly like this. They're oftentimes accompanied by really gusty winds too, sometimes to 60 miles per hour. So in addition to just the sand, which can cause widespread issues, things get kind of sandblasted. It might strip paint off homes. You'll have wind damage too. It's crazy. You never want to breathe it in though. So this man does the right thing. He has a cloth over his face to protect against breathing that sand in. Yeah, and just look at the color of the light. It looks like something you'd see on a different planet. Really, sandstorms change light to look almost like Mars. It's bizarre. After a while, visibility starts to improve a little bit as I get on the backside. The light starts to poke out a little bit more, but really, I gotta say, they did a phenomenal job with this scene. This one is realistic. It is accurate scientifically. 2 thumbs up for the first time. So I gotta say, I think Twister was probably my favorite, even though it's tough as a meteorologist not to overanalyze. That's the biggest thing. When you're a meteorologist, you overanalyze all the weather themes, whether or not they're trying to be silly and goofy like Sharknado, or if they're actually trying to adhere to the science. But Don't go to Hollywood for real-term scientific explanations. Just don't do it. All told, it was a fun time. Looked at a lot of cool movies, and I think I have a lot of stuff that I gotta watch. Thanks so much for watching. We'll see you next time.
Follow MyRadar on social media: Facebook, Twitter, Instagram, and YouTube. Download MyRadar on iOS, Android, Amazon Alexa, Xbox, and Windows.